Hello, this is a short video presentation on special cases. We're going to look at the system of equations shown here, and we're going to solve it by graphing, by substitution, by elimination, and we're going to see what happens. So first, let's do it by graphing. The first equation, very simple to graph because we're in slope-intercept form. So I go up 1, 2, 3, 4. And we go down to right 3, down to right 3, down to right 3, or up to left 3. And now I can draw my line. Oops. See if I can do a better job. All right. Sorry about that. And there's my line. Now 2x plus 3y equals 6 is in a form, standard form. I see that it's easy to solve this, graph this, by using the x and y intercept. If x is 0, 3y equals 6, y equals 2. So on the y-axis, I'm at 2. And when y is 0, 2x equals 6, x is equal to 3. I go right here, and I'm going to draw my line. So, booyah. I notice the lines are parallel. What's the answer? Parallel lines means no solution. So we know that this system of equations has no solution. Let's look. Why no solution? Ask yourself that. Why? All right? Let's think about that. All right. Now let's look at substitution. All right. Since I'm already solved for y, I'm going to just substitute y in here for y. However, it's going to be a little bit less than desirable because I'm dealing with fractions, but so be it. So I'm going to put y in there, and I get 2x plus 3 times equals 6. And in here, I'm going to put negative 2/3 x plus 4. And then I distribute 2x plus 3 times negative 2/3. Fortunately, the 3's will cancel. Negative 2x plus 3 times 4 is 12. 12 is equal to 6. 2x plus negative 2x cancel. 0x plus 12 equals 6. 0x is just 0. 0 plus 12 equals 6. And 0 plus 12 is 12. 12 equals 6. An obviously false statement. Just like before, false statement, no solution. And it's false because the x is canceled and we have two numbers that aren't equal. Okay? If the x doesn't cancel, there will be an answer. All right, let's look at solving by elimination. All right, let's start solving. First of all, I'm going to multiply this by 3. This is going to stay the same. So I have 3y equals negative 2x plus 12. Showing I'm multiplying by 3. So I have 2x plus 3y equals 6. Then I'm going to just put it in standard form, add 2x to both sides. 2x plus 3y equals 12. 2x plus 3y equals 6. And I subtract to get rid of my x's. I'm sorry, I'm going to multiply by negative 1. Not going to subtract. And I end up with this. All right? I add to get rid of my x's. Those cancel. Wow, my y's cancel too. I got rid of all variables. 0 equals 6. And just like before, an obviously false statement, no x's around, false statement means no solution. All right, now let's go back up here, and we are going to look at two different equations. So let me pause this for a moment and clean it up. All right, let's begin by graphing the first equation. I'm sorry, the second equation. Much easier to graph slope-intercept. Well, nah, let's do it the other way around. All right, 2x minus 3y equals 6. If x is 0, y equals 3. 2x equals 6. I'm sorry, x equals 3. I'm looking at the first equation here. So x is 3. And when x is 0, y is, let's scratch that. That's not correct, Musket. Sorry for wasting your time there, guys. All right, let's try this again. When x is 0, negative 3y equals 6, y equals negative 2. So right here is my point. And when y is 0, 2x equals 6, x is 3. And right here is my point. All right, so now let's draw our line and get this to line up. Our line looks like that. Now we're going to go to the next equation, this one right here, and 2/3 x minus 2, slope-intercept is 2. I'm sorry, minus 2. We go here, up to right 3, up to, oh, I'm on the same line. Up to right, oh, it is definitely down to, yeah, how'd that happen? Exact same line, all right? Same line means there's an infinite point of intersection, infinite solutions. And we don't say identity. This is not an identity. It just means there's an infinite set of solutions. All right, let's look at substitution, and then we will quickly do elimination. So let's pause this. All right, solving by substitution, y is by itself. So I'm going to substitute into this equation for y. And I get 2x minus 3 times y equals 6. And y is 2/3 x minus 2. The 2x Distribute, my 3's cancel, minus 2x, negative times negative is positive, 2x minus 2x is 0, just like before, 0x, which is 0. I get 6 equals 6. No variable, no variable, true statement, means infinite solutions. And lastly, let's look at these two equations, and we'll solve by elimination and see what happens. And then we're done. All right, we're going to solve by elimination here. First of all, I'm going to multiply by 3. Get rid of the fraction. 3y equals negative 2x minus 6. This equation stays the same. 2x minus 3y equals 6. Now I'm going to add 2x to both sides, put it in standard form, and I get 2x. Hold on a second. Okay, I know I made a mistake. 3 times y is 3y. 3 times 2/3 is positive 2. It's positive 2. And 3 times negative 2 is negative 6. All right. Now I subtract 2x to both sides, and I get negative 2x plus 3y equals negative 6. And here, this stays the same. 2x minus 3y equals positive 6. Add them together to get rid of the x's. Those cancel. Y's cancel also. And I get 0 equals negative 6 plus 6 is 0. Once again, an obviously true statement. True statement. No variable. There is an infinite number of solutions. Infinite solutions. All right. From here on out, when we solve systems of equations, including your test, you will have cases where there is either no solution or infinite solutions. All right. Sorry about the length of this video, but that's all right. Have a great day, guys, and I'll see you later.